This is question 21 on the higher calculator paper. Now, looking at this question, it occupies the whole page, and I've just looked at or zoomed in on part A, and here is the question itself. Here are 7 tiles. There's 7 tiles altogether. Jim takes at random a tile. He does not replace the tile. That's really, really important. They put not as bold. So Jim then takes at random a second tile. So he picks 2 tiles from this pile and he doesn't replace the first one. Calculate the probability that both the tiles that Jim takes have the number 1 on them. Okay, this is a probability question, and because he's picking from a sample and he's making 2 picks, I'm going to use a tree diagram to show this. Right, there are other ways you could do it, potentially shorter ways, but I'm going to use a tree diagram nonetheless. I put 3 branches because there are 3 different results he could get when he picks a tile. He could either get a 1, or a 2, or a 3. So he either gets 1, 2, or 3. Right? When he picks the second tile, he can get 3 possible results as well. Okay, and again he can get a 1, 2, or 3, a 1, a 2, a 3, or 1, 2, 3. Okay, the question says calculate the probability that both the tiles Jim takes have the number 1 on them. So we want to work out the probability after his first pick he got a 1, and after his second pick he got a 1. So we're interested in that branch at the top there. What we're actually interested in, I'll highlight it, is this path. 1 followed by another 1. Okay. On his first pick, what's the probability that he'll pick a 1? Well, there's 7 tiles altogether, so the probability is going to be out of 7. And 2 of the tiles are 1, so it's 2 over 7. Now, if he does not replace the tile, right, after he's picked 1 tile, there's going to be, if he picks 1 tile with the number 1 on it, he'll have 6 tiles left behind, and of those 6 left behind, only 1 of them is going to have the number 1 on it. So the probability of picking a 1 the second time is going to be 1 out of 6, 1 over 6. And to calculate that he picks a 1 first and a 1 second, because it's an AND probability, I need to times. Okay, because it's an AND probability, you multiply. So I'm going to do 2 over 7 times 1 over 6. 2 times 1 is 2. 7 times 6 is 42. The question doesn't say anything about simplifying your answer, so I could simply put 2 over 42 as my answer to this, and that's about it. This is a pretty straightforward question, and if you're familiar with tree diagrams and probability, you should be able to get it. The key thing to remember here is that after the second pick, there's 1 less tile, right? 1 of them would disappear. There's 1 less tile, so the probability of picking a 1 your second time is 1 over 6. Okay, going on to part B. Okay, in part B, it says calculate the probability that the number on the second tile Jim takes is greater than the number on the first tile. So you want to work out the probability that the number on the second tile is bigger than the number on the first tile. Okay, to do this, I'm going to go back to my tree diagram from the previous part. I'm going to try to keep both of them together there. Okay. Now, going back to exactly what the question asked, it says, calculate the probability that the number on the second tile Jim takes is greater than the number on the first tile that he takes. So, these are all the second tiles, right? And this is the tile that he gets in the first pick. So, if he picks a 1 the first time, right, what's the probability that he will pick the second tile is greater? So I'm interested in the result there. So that if he picks a 1 the first time, what's the probability he'll pick a 2 the second time? So that's 1, and then picking a 1 the first time and a 3 the second time, so that is one that I'm interested in as well. If he picks a 2 the first time, then I'm not interested in him picking a 1 or a 2. I am interested in the probability of him picking a 3 the second time, because 3 is greater than 2. Okay, and if he picks a 3 the first time, well, none of the numbers are going to be greater than 3. Right? It's 1, 2, and 3, so none of these. So I'm interested in working out those 3 probabilities. So the probability for picking a 1 and a 2, this branch here, and the probability of picking a 2 the second time, and in fact, let me fill out these probabilities here. There are 3 2's altogether, so this one here would be 3 out of 7, and there are 2 3's, so that's going to be 2 out of 7. And just check this, 2 plus 3 is 5, plus 2 is 7, so all of these are correct. If he picks 1 the first time, he's going to have 6 tiles left behind, so the probability of picking a 2 here is going to be 3 out of 7, and the probability of picking a 3 is going to be 2. No, 3 out of 7, 3 out of 6, and this is going to be 2 out of 6. Just check this, 1, 4, 6, so those are correct, and all I need to do here is to work out the probability of picking a 3 here the second time round. So if you picked a 2 the first time, there'll be 6 tiles left behind, and how many 3's were there? There were 2 3's, so that would be 2 out of 6. Okay, so to work out the probability of picking a 1 and then a 2, it's going to be 2 over 7 times 3 over 6. The probability of picking a 1 the first time and a 3 the second time, 1 and a 3, that's going to be 2 over 7 times 2 over 6. And the last one is going to be picking a 2 the first time and then a 3 second. So the probability of picking a 2 and then a 3. So 2 the first time is 3 over 7, and then times that by 2 over 6. Now I need to work out each of these 3. So 2 7s times 3 6. 2 times 3 is 6. 7 times 6 is 42. 2 times 2 is 4. 7 times 6 still 42. And 3 times 2 is 6, and that's going to be over 42. And I need to add all 3 of these. 6 over 42, 4 over 42, and 6 over 42. 6 add 4 is 10. 10 add 6 is 16. So that gives me 16, and because they're all out of 42, my answer is going to be 16 over 42. And that's the probability that the second tile Jim takes is greater than the number on the first tile he takes. Okay, this is a particularly complex problem. It's not impossible, right? But you need to take your time, think about it, and some basic knowledge of tree diagrams will help you work this out. Make sure you do this question yourself, make sure you understand it, make sure you can get full marks in it.